We have some more vocab to start off with. A central angle. An angle whose vertex is the center of the circle. So if I want to draw myself a central angle, so let's say there's the center of my circle. Oh, whoops. There's the center of my circle, and then I would just draw 2 radii, and I've created this angle for myself. We refer to that as a central angle. So any angle whose vertex is the center of the circle. Okay. Then, actually, I'm gonna extend this and make a diameter, and I'm gonna throw some letters on here. A, B, C, and we'll call the center D. So, by the way, I'm not sure where it comes up in this, but to name circles, you just name it by whatever their center point is. So this would just be circle D. And how do I know for sure that D is the center? We always assume that it is. So usually there will be a dot. So if I wanted to show you, for example, so say I had something like this, right? And I wanted to show you a chord that wasn't a diameter. You always have a dot in the circle, and then maybe it would go like this. So you wouldn't be confused, right? So you know, okay, clearly that's not a diameter because that's my center point and it doesn't go through that. So that would just be some random chord. All right? So when you see the dot in the middle, you're just assuming that that's the center. Okay? So if you saw something like this, did I just draw a central angle? Is this a central angle right here? No, because its vertex is not the center of the circle. So that would not be a central angle. All right. So here I have my little diagram. And now what I've done with the edge of the circle is I've broken it up into pieces. These pieces we refer to as arcs. Okay? So I have arc BC here, for example. Now, arc BC is different from segment BC. Segment BC is if you drew literally a straight line from B to C. That is segment BC that we would indicate with the line on top, right? So segment BC, straight line. If you walked, pretend you're on the track and it's on a curve, if you really walk the curve from B to C, that's different. We refer to that as arc BC. And to do an arc, you literally just put an arc on the top and then B and C underneath. So the notation is really important. Straight line above it really means segment. You draw a straight line from B to C. Arc on top means along the curve from B to C. So does that make sense? Is that clear, that difference? Straight line along the curve? Okay. So now, as far as arcs go, we have different types of arcs. We have minor arc, major arc, and then, well, let's just start with those two. What do you suppose a minor arc might be? Do we have minor arcs and major arcs? Yeah.
Minor arc is one that doesn't really like arc that much, kind of like more flat.
You're on the right track, sort of. Yeah.
Is a minor arc like less than half?
Yeah, it's just an arc that's less than half the circle. Okay? So, if you look under arc, see it says it kind of in little letters. So a minor arc is less than half the circle. So a major arc, well, actually, let's stick with minor arc. To name minor arcs, you just use 2 letters. To name, use 2 letters. Order doesn't matter, just like if you're naming a segment, like segment AB and segment BA are the same thing. Same goes for arcs, for minor arcs, I should say. So minor arcs. If I want to talk about arc BC or arc CB, same thing. Use 2 letters, which are the endpoints. Now, a major arc obviously would measure more than half the circle, right? So major arc more than 1/2 the circle. So let's go back to my drawing if you don't mind. Oh wait, whoop, sorry. Let's say that you started at B, right? You're out for your daily walk, and you walk this way. And you stop there. If you call that arc BC, yeah, that doesn't make sense because arc BC was this one. And you're like, hey, don't cheat me out of all my steps. I went all this way. So we need a different way to name this arc than this one, yeah.
Arc VAC.
Right. So you have to use 3 letters. So major arcs use 3 letters. The endpoints are going to be the same. And then you can pick any other point you pass along the way. But it's got to be on the edge of the circle. So you couldn't say BDC because D is not on the edge of the circle, right? But if I had, I don't know, if I had another point here that was F, you could say BFC, BAC, and you could go the other way. It doesn't matter. CFB, CAB. You just want your first and last letters to be the endpoint, and the point in the middle, anybody along the way. Okay? So 3 letters is assigned to you that it's probably a major arc, and then you know which way to go, right? So if I saw, I don't know, if I saw someone write down arc BAC, I know to go from B, then immediately to A, and then I end up at C. You wouldn't go from B past C and then end up, right? Like, that doesn't make any sense. So this, the way that the arc is named, kind of tells you which way to go. From B, I would then go to A, so I wouldn't be going this way, I'd go that way. And then I'd end at C. Okay? So, major arcs, we're going to name them 3 letters. Named with 3 letters. And so it's first and last are the endpoints. First and last are endpoints. Middle is any along the way. So those are called major arcs. And then there's one more type of arc, because you can have less than half, you can have more than half, but what happens when you have exactly half?
Semicircle.
Right, we call those semicircles. Do you suppose you need 2 letters or 3 letters to name a semicircle?
Two. Probably 3.
We still use 3, only because, so in my picture right here, first of all, are there any semicircles drawn?
Yes.
Yeah. Here's, because you know that this is the center, you know that this is a diameter. I don't have to come out and tell you. Okay, so if I have a straight line segment, right, whose endpoints are on the edge of the circle and it passes through the center, it's a diameter. So I don't have to come out and tell you that CA is a diameter. I can, but I don't have to. The diagram is enough. So as long as you see a straight line going through the center, you know it's a diameter. So that would mean that this would be half a circle and this would be half a circle. If you just talked about arc CA, we just don't know which way you're going. Are you going this way or are you going that way? So we still usually use 3 letters for a semicircle. Okay, so semicircles are exactly half. Gosh, there's really not a lot of room on this sheet at all. So semicircles, semicircle, exactly half, 1/2, still use 3 letters. And then what do you suppose adjacent arcs are? Like, if I go back to my diagram, can you name for me a pair of adjacent arcs?
AC and CF.
Yeah, it's just 2 arcs that are right next to each other that would share a common endpoint. So arc BC and arc CF would be adjacent. There's plenty of them. Arc CB and BA. Arc BAF and FC. Tons. Okay, so they're just arcs right next to each other. And similarly, so remember if you had, adjacent angles, okay? Remember, oh, they took all my markers. Oh, they're all over there. I only got one here. You think it's dry erase?
No.
There's not even a point on it. What the heck? Oh, God. Who is this? Who is this out here? Who's not recycling their cans? Aren't you guys supposed to be like environmentally conscious?
We're barely conscious.
That was funny. Alright, so remember adjacent angles? So if I had like a 30 degree and a 10 degree, what can you do? Add them together and it equals the whole thing. Same thing with the arc. So if I have two adjacent arcs, I could add their measures together and get the length of the whole arc. So, arc addition. If you want to say this, you can say, let's see, how could we put this? You can add two adjacent arcs to get measure of larger arc. That's good. How do you find the measure of an arc? Huh.
Magic?
Well, there's two different ways that we talk about it. The easy way is in degrees. How many degrees in a whole circle? 360. So if your arc was 1/4 of the circle, what's the measure of your arc in degrees? 90. So it's actually, believe it or not, every time you have an arc, the arc is related to a central angle. So if I talk about arc BC, this minor arc, if I just have the radii from B and C, it creates this central angle, right? Whatever the measure of the central angle is the measure of the arc. So if I told you that this angle was 80 degrees, then arc BC would be 80 degrees. So, tell me what the measure of arc BA would be. 100, wouldn't it? Because remember, this is a straight line. So if that's 80, this is 100. And so if this central angle is 100, then its arc, sometimes we refer to it as its intercepted arc, would also have a measure of 100 degrees. What would the measure of arc CFA be? 180 degrees. What would the measure of arc CFB be? 280 degrees. You see this? How this works? Easy peasy? Okay, good. So that's the really easy way. The measure of the arc is the same as the measure of its central angle. Now, what if you literally walked from B to C, right? You're out on your lunch break. You're like, oh, I'm going to go for a brisk walk. And someone's like, oh, how far did you get to walk on your lunch break? And you said 80 degrees. Right? That makes no sense. So there's a difference between that and if you literally walk that and you want to know that distance in feet, miles, meters, whatever, that's called arc length. And we do that later in the chapter. Where's arc length? That might actually be chapter 10 even. Arc length. I'm not even seeing it on here, but it's different. And we do it later. So I'm going to save it for later. But for right now, it's just the measure of the angle. So we're talking about them in degrees. Yeah. Sure. Okay, so the measure of an arc of an angle is equal to the measure of its central angle. Oh, it would not have an apostrophe on it. Silly goose. Of its central angle. And two arcs are congruent if they have the same measure on the same circle or congruent circles. Okay, so if I have, I don't know, say I did something like this. Here's my circle, there's the center, and I did this. Without me doing anything else, you know a whole bunch of congruent arcs. Just by me drawing just that. Give me a pair of congruent arcs. A, B, and DC, you're saying. I agree with you. How do you know that? Right. Remember, vertical angles are always congruent. So, even though I don't know their measure, if these two angles are the same, their two arcs are going to be the same. So, arc AB and arc DC would have to be congruent. So, we can even write it. Arc AB would have to be congruent to arc DC. Give me another pair.
AD and BC.
AD and BC for the same reason. AD congruent to BC. You have any more?
ADC and ABC.
Yeah, the semicircles, right? So you could say ADC and CBA. Did you say? But that, oh, no. Okay. Yeah, I'm sure we could keep going. Now, I could also do, let's say I had another, let's just say that the radius here was 4. If I had another circle over here that had a measure of 4. And I knew, so yes, these two angles are the same, but then I also knew I did something like this, and this angle's the same. So all 3 of these angles are the same. I get to automatically say, I don't know, PQ. Arc PQ would be also congruent to arc AB and DC, even though they're not in the same triangle. They're not in the same circle, but they're in congruent circles. So, same thing applies. If I have 2 arcs and the same circle or congruent circles with the same central angle, all the arcs would be the same. Does that make sense? Easy enough? Yeah? Okay.